Alright, so we're back at it again. I think we can hear each other well. This is our new day, it's a new dawn, and look. Okay. So I got an idea for our little algorithm. Again, the first part was explained. So with with a certain coordinate system, Cartesian coordinate system, here is 0, there's 1, 2, 3, and here is 1, here is 2, here is 3. We have a certain system, and now, for example, we have one point over here. Can we make that an X? It's so hard to draw over here. Wait, I'll get a mouse. Alright, I'm back with this mouse, so it's better. So let's say this is one point. So currently, like, there are gonna be two faces. Phase 1. Like, none of these things is normal. Look, like, calligraphy, I don't need to explain why this is not normal, but this pencil thing over here is not normal. It seems most normal, but if I want to make an angle, look, it's like, I mean, can you see it? Like, if I do H, look, H is, okay, now it's nice H, but look, like, it takes it with it. And if we pick up this pen, yeah, you see there's something weird going on, which can, with like maybe streamer, yeah, that's also weird. I don't need to explain why that is weird. And crayon is, I guess, the most normal thing. So let's use crayon with how much? Yeah, it's nice. Phase 1. So we got, let's say we got 3 points, or 4, let's say 4. Here's 1, 2, so -1. We're over here. Here is 1 point, here is 1 point, and here is 1 point. So right now we've got points at 0, 0. Then we've got 1, 1, 1, 1. Then we've got 1, 2, 3, 1. So we got 3, 1, 3, 1. And we've got -1, -2. So we got -1, -2. So those are our 3 points. Now the question is, like, where is the, to calculate all of these points? So we first do a calculation, and we do, so these are quadrants, like let's say this is first quadrant, that is second quadrant, that is third quadrant, and that is fourth quadrant. Like, so the first step is to figure out, where's the text? Where's the text thingy? Where is the text thingy? Star. Nope. Ah, it's over here. Oh, it's too big, man. Too big. It's a little bit too big. Yeah. Okay. So we say over here, oh, and we need to move it, you know. We need to, oh fuck, how do we move it? Ah, damn. Okay. Let's say figure out which point is the nearest to which point. Oh, now I don't know where I am in the text, so I have to move it. Oh my god. No, man. Select and move. And I want that to be that big. No. Options. So we'll say delete options. No, I don't want. Fuck. Styles. Line height. Where is the size of the text, man? What? Shit. Alright. And at which point is like get the point that moving line shall collide with first. Alright, so that's first thing. Let's make that a little bit smaller. Alright, that's good. So say get the point that moving line shall collide with first. So how do we do that? We say we shall do it by oh my god. Oh shit, I don't want to look at it. We shall find out the now I need to go to the tool. Fuck, I don't want fuck, man. Okay. Alright, I'm back from the lavatory. And so how do we get the point that the moving line shall collide with first? Well, if this axis, if we just take this axis as a moving line, it shall gonna, oops, can we select it like so? Just a little bit, it shall be moving like this. Wow, I have drawn it quite splendidly. So it shall move like this way. So first it shall encounter this one. Damn it. So it shall encounter it like you see in the fourth quadrant. So this shall be the first one, shall be the second one, and this shall be the third one. So we have to measure from two ways. First we measure angles from over here, and then we also measure angles from over here, and we must calculate angles. It's so weird. Do you see like the point on the top of the pencil is over here? So when I actually draws from somewhere else. Well, that's what I get, I guess, for using this free application. Okay. Alright, whatever. So yeah, one over here and one over there, that's the thing. And how do we do that? Well, first of all, regarding that, like this and here is the same as that we can first that we can copy points from fourth quadrant to the second quadrant, and from the first quadrant to the third quadrant. So we say copy points from 4 to 2 and from 1 2 3 1 2 3, yeah. 1 2 3, not 1 2 3 like the number, but 1 2 3, you know what I mean. So how do we do that? Like like how do we recognize the points that are in the fourth quadrant? And because their form looks something like that. It's so here is the like this, like the first quadrant can be expressed as, so x is minus, so we say minus plus. The second quadrant can be expressed as plus 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 plus. The third quadrant can be expressed as plus minus minus, and the fourth quadrant can be just expressed as minus minus, because y axis, I mean x axis is minus and y axis is also minus over here. So we do so for that we just change every like, so how, like this, if we erase that or just like carry that over here, let's say every we take that, we pick out basically any point that's like, for example, minus a and minus b, and change that into just a b, yeah, just like so. We do that, and also this one. Well, and from when we do from 1 to 3, we do from minus plus to plus minus. So if we got minus a and b, we turn that, and minus can be like less than 0, you know, or more than 0 for plus. This is turned to plus a and minus b is z. So first we move that, and now you may be asking, yo, what about the lines with 0 something, you know? What about lines with, and it's simple actually. The line, I think we can expect that if like line starts over here, that it won't then immediately one point be on this line that's starting it. So we can expect points that will be over here or over here. And so we say we can have a shortcut. So first we say if the point is that x is 0 and y is something else, and we can have a point that x is x and y is 0, you know, and that immediately translates to, so we say if x is 0, so the point lies here, that immediately means that there is a 90-degree angle, and if the y is 0, that means it's probably over here. I mean, if it's possible that it lies over here, we're kind of fucked. Let's just see of all the, like, I guess the person did like Desmus of all the possibilities. you can see all the static tests in Desmos. So yeah, here is one. Here we see they're not on the line. This is a bit larger now, square. It's okay. Like this, like that, as a matter of fact. Alright. Pac-Man. Triangle in circle. Like right now I'm just looking for if there is anything that starts with here and another point is also on just on this y-axis. L face, no, double triangle, double square, also not, double pentagon, also not, yeah. Or we can also just say like, also here is impossible actually. Also here is impossible, but because here also it is started. So I guess that's not a valid, I guess that's not even a valid option. Go back, yeah, and only here we say 90 degrees. Can there be more degrees? I guess not. So yeah, so we do that. We say so first, yeah, we copy points. This should be written, this should read points, and over here shall do the second one. The second thing what we shall do is to measure angle to measure angle. And then, like, you know what the third point is. I think I shall need some kind of space over here. Yeah, let's make a short break for our eyes. And the third point shall be get the point that's moving line like just 3. I should just write the text here. And the controller fucking inverted, man. So we shall say just point with the lowest angle is hit first by moving line. So make that smaller, put it over here. So that is just the end of the first step, you know. We're over here. So how do we measure angle? Well, basically now we have points in the second and the third quadrant, and the first quadrant is, I think, quite simple because it's moving this way. We say, and this is also here, so this is copied over here. I'm gonna make a different color for the copied ones. How do we want our copied ones? let's make green. That shall be copied over here, and that's it. And so what shall happen with this moving one? It shall this is copied, and this is for the angles. It shall hit here, so the line shall be tilted like so, creating an angle over here, an angle alpha. And how do we measure that angle alpha? Well, we know the length of this line. We know the length of this line, and this line constructs a triangle. We also know the length of this line. Oh, fuck me. Shit, let's backtrack. Yeah. Let's go a little bit closer. We write that line better. So we know the length of this line. We can calculate the length of this line. We can also We can also calculate the length of this line. And we can also calculate the length of this line. And this is the angle that we are interested in. So, and this is 90-degree angle, and we can, as said before, we can solve that with triangulation, or triangle, like, you know, котная функция. Also this one, you know, here over here, we know the length of this line, and now like so, we're interested in this angle, see? Well, here is a little bit different story. If we go down there to, for example, oh, we have none points over here. Now let's make a fake point. Let's say we have also we have 1 point over here, +2 -2. So how do we get an angle over there? Well, here we invert it a little bit, embedje, because from the center to over here. So yeah, like let's first verbalize a formula for this one. So we say if the length of this thing, this is alpha, so let's say this is, oh no, let's say just that this is x and this is y and this is just L length, and this is the, let's say this is alpha, I think that we're looking for. This is kind of against the classical mathematical conventions, I guess, but it's not a problem. So we know basically everything, every line, and even one angle, and we just use this thing. If we're, yeah, basically it's tilted. So this is x, this is y, this is L, and we're interested in alpha. So we can just use sinus, where we say sinus alpha. Here we say basically sinus alpha equals to, so sinus alpha equals to A divided by C, so that's x divided by L, so that's x divided by L. And how do we get alpha out of sinus alpha? So we say yeah, how do we get alpha out of sinus alpha? So say get degrees out of sinus Sine calculator. There is a calculator, so we can do it. Reverse sine, so we say if sinus is 3. I think that's way too much. I think sinus can be from 0.5 or something. 0.5. Well, inverse sine calculator. I don't get it. Cosine sine. I mean, in this, so in this thing, x is 1 and we divide it by how much is L, so this is x times y, so x 1, and this is 1 plus 4, 5, so this is 5. This is basically the length of this L, and that is sine A. So we just say, we don't need that, we say online calculator. We say where is that? Cancel. We say 1 divided by 5 . That's 1. We just copy that whole number. I guess we gave it here. This is sine that, so that is that. I don't know what are we calculating, but if we inverse that, that's 26.56 degrees. Yeah, so then we have to figure that out, how to get get degrees. So we say Python get degrees of a triangle. Math equals degrees. Yeah. He doesn't know how to calculate. Math cos math degrees dot angle. Okay. You can get angle and then degrees. A little bit more complicated than that. You need to use the law of cosines. Okay. Yeah, like that's also what we can do. Law of cosines. Cosinus. That I guess this for the guy that has to make sure. Alright, so it's a little more, you need to use the law of cosines. So we got A, B, C, that's like X, Y, and L. From math, import A cos and degrees. Degrees, A cos A times B times B times C divided by 2.0. 2.0 times A times B. 2.0 times B times D cosine A. I guess. This is accurate to 4 significant figures. If you provide more precise value of C, you get a more accurate result. Alright, so we got our solution over here. So that's just another matter. I guess that is, oh shit. We'll have to, apparently, we'll have to use the math module, which is nice. First time using math module, why not? Yeah. So we say over here yeah, and I guess we shall rename that. If that is A, that is A, that is B. Fuck. This is B and that is C, and we're interested in alpha. We'll just like calculate. Oh, measure angle. So here we'll just write calculate I can't write alpha, but alpha angle of points in second quadrant. Alright. Alrighty then. Alrighty. Calculate A angle of points in second quadrant, and if we are over here in the third quadrant, what do? We have it somehow like so. We have a triangle over here, and that is X property again, that is Y property, and that is just the length, like the distance from the middle to over here, which can be easily calculated also. And here we are interested in this point. So again, we say, and here we just say calculate angle of A minus 180 degrees. What is the, I hope this is degrees. Angle 180 degrees for points, oh shit, for points in third quadrant. Alright, make that smaller, we move that over there, then we make a pause again. Yeah, I'm back. So yeah, we have now angles of all of them. At this point, so you say get the point that moving line shall collide with first. And here it should say it shall collide with first, and the angle it needs to traverse to get there. Alright, so now we got the point and the angle. So the second step I have used all of this for the first step. So if you export that to download .sketchpad, can you open .sketchpad? Got some older drawings over here. So we just make a new drawing, I guess, or we just download this .pdf, I guess. Drawing sketchpad in planning sticker project. Well, no, it's something else. I just do it over here, general programming. And Then the second step shall be pardon, yeah, second step I see that second step is just to it's really simple. We just increment the number of degrees traversed and increment the, how do we call that, the cumulative hits, increment the cumulative hits by 1. Well, I am a little so yeah, that is the second step. And like the third step is up until now for me the most complicated one. So here we say third step we say which is what we shall do is we say make the hit point the new center of, how do we call coordinatny system in English? Of coordinate system. Yeah. The new center of coordinate system. Alright, so that is the third step. Which is we have to figure that out, how to do that. Make the hit point the new center of coordinate system, and yeah. The new center of coordinate system, and then we shall just say fourth step. Just say fourth step. Fourth step is to just repeat steps 1 through 3 until number of degrees exceeds 360. Then return number of cumulative hits, but you all actually need to decrease it by 1, I think. Now that I'm thinking in advance, I think that you first have to decrease it by 1. We shall get to that later, but that's the basic logic of what I am trying to achieve right now. Alright, so now we know the second step. Now I'm gonna make a sketch of the third step, and then we shall kind of visually test our steps. So I wonder with my little eye, if we say sketchpad app over here, if we open another instance over here and we open this one, alright, and then we select all of these elements and just say copy, we paste them here, nice one, and we just move that, nice, and we just take our select tool, we delete that, oh shit, we delete that, we delete that, we delete that, we would be better off just drawing a whole new coordinate system, yeah. We just say, use this black one, and we make a straight line. Can we make a straight line? Shit. Alright. Maybe we need to make like from here to here. Straight line, right? Alright. Nice one. Make a straight line over here. Kind of, yeah. Great. You're finished, thank you. Then we on it we mark certain points with our little crayon tool. Here is 0th one, and here we say 1, 2, and here we also say 1, 2. Well, what do we say? Well, let's say we have a point here, we have a point here, and then we also -1, -2, we have a point here. Let's say these are 3 points, and let's say that we have already collided with this point over here, so we got point, this is that, oh, always, there is always this point, so this is also a point, always a point, this point, so we say A, B, C, D. I just name our points A, B, C, D. C is a little bit, now it's better. So we got points A, B, C, D. Now we say we start off from point here, and then we hit, like, then we hit this point B. So make a line, make it a different color. We say go from here to here, and to make that longer over here, make that also longer over here. So is that kind of correct? Yes, that is correct. Nice one. So now we must kind of shift our perspective, because now with the third step, make the hit point the new center of coordinate system. So what happens now, that now this point B is 0, 0. And now what happens is that if we're at point B, we want to make so this, so now this, where the fuck is crayon? So now this line is our Y line over here. This is our Y line, and the thing that is square, I mean, okay, pravokutna. I don't know English terms for math shit. I don't know all the English terms for math shit. Yeah, but that way we, oh fuck, we also get the x-axis, which somehow, which looks somewhat like this. So this is our x-axis, and this is our new x-axis. That's an X. Alright, that's our X-axis, you know. So how do we get then like the new coordinates of these points? Because like at first, let's say just how they were at first, and let's just use this one. It's easy because oops, before A was 0 0, B was what, 1 2, C was 1 1, and D was 2 minus 2. That's about it. So those are the points at the first instance. They're over here. But now the things shall be different.
Yeah, you were used to do what was before, well, now things around here are different. Yeah.
And the fill outline, the fill shall be this color. Yeah? And your text here, you know. So now we shall start with B point, which will be 0 0. Now B point is 0 0. We make that ambitious smaller. Put it over there. Yeah, like so. So now B point is 0 0 if we look like so, and the like, yeah, now the question is how do we get the coordinates of all of the other ones? So that is the hardest point. Let's figure that out now. And what can we say is that oh, also the thing that we can also say for certain is not only that B is 0 0. Let's give this div a bit more space, but A is what it is. Its X is 0 and Y is just Y for now. We don't know it. And C we don't know, and D we also do not know. Yeah, but how do we get them? Mathematically, programmatically, mathematically, and thematically, yeah. Now, so, yeah, this can seem a little bit tricky, and it is tricky, but I thought about it, like when we change the center from here to here, what do we change? First, we move, let's use blue color. First, we move the center 1 point in the x-axis and 2 points in the y-axis. And after that, we tilt it for this angle, which is alpha from the first step. So what we can also do is to first tilt, what happened? Is to first tilt and then move. And how do we tilt? If we first tilt for alpha, and right now I'm just wondering how can I draw circles? Path, circle, where's the circle, man? This is web, span, the children are loud. Mirror brush, paint brush, I think Desmos would be more useful here, but we say if all of those points are in if all of those points are on a circle around the center of the coordinate system, like for example there is a sun and there we got Earth and Jupiter and Neptune, So we can write, oh, this is a bad circle. Wow, that's an ugly circle. Do we have a tool maybe? Star. Ah, we've got circle, right? Can we make a circle? Ah, nice. We can make a circle, so let's make a circle and let it be filled with nothing. Can we drive its opacity to nothing? Set fill opacity to nothing, and outline shall be let's say just purple. And let's make a center of that. Say over here. Well, is that in the center? Shit. Let it be in the center over there. And we say, shit. Okay. Here we like, oh no. Oh, bamboozled. Oh, the big bamboozle. Why are you Romeo? No, 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 no. Oh, no, no, no. Yeah, exit that. Gotta make another circle. Let's make it from over here. Cancel, like from over here. Alright, so to capture that C, alright, nice. So that's this C circle. Now we got another one. Shit. Oh my god. Alright, that's good enough, I guess. Or is it? I guess it is. But they're so different, man. They're so different. But they start kind of similarly. Look! What? Oh, what the fuck, man? Shit, that's fucked up. That's proper fucked up. So, okay, let's just make a copy of the same circle. Like you, motherfucker, you started like over here. Right? And you go through C and you make a copy of it. These copies are sloppy as fuck. Wow, this is impossible, man. Choose shape. I guess. The width and height should be all the same. Wow, this is a nightmare right now. Oh my god. I cannot work professionally that way. Where's this shitty circle? There are two circles. I want to select that circle. I wanted to not move it. Okay. Fuck. Okay, oh, alright, I got it. So that's B and that's D, so let's pick this one, D. Alright, so alright, that's over. We could also like pick this one, B, if we can. Alright, it overlaps C and now it overlaps B. Alright, that's great. So we have these circles and alright, so I think this is kind of the right way, because yeah, and we're in this phase, we want to pick this one, this color purple, and we go with that angle. Shit. We go with that angle. We got A. So nice one. We got A thingy. And move B to there. So in essence, what do? We want to move by making this the center. We calculate this. We calculate this. We calculate the кружница, курац. Where is the Slovenian language, English? The circle, you know. Calculate the circle. This guy was very smart, I guess. Area, Cartesian coordinates, and the circle is always in the center, so it's x on 2, y2 is radius 2, x2, y2 is radius 2. That's the reality of our circles. So we say this is always x2 plus, is it plus? It's plus. x2 plus y2 is radius 2. And radius is the same as L from the step before, you know? So from radius now, we wanna move so this thing, we wanna move the B thing over here first and then down. So we wanna make B oh, I get it. First we like make the B's expression for the circle, so it is x is for the B circle, so we say x times 2, that's x times 2 is 1 times 2 plus y2, and y is 2 plus 2 equals r2, which is r. That line is just like exactly that. N на квадрат plus 2 на квадрат is that too. And that is exactly that. I mean, it's fuck, how much is it? How much is it? It is a little bit more than 2. 1, 2 plus 2, 2, that's 5. So that's exactly 5. Alright, so that's 5. And if we wanna move B over there, we just say y, because in that case x is actually 0. So we say x is 0, and we want to know the y, you know, we want to know the y, which is incidentally the same as radius, that is equal to the radius, our y on 2 is radius by 2, which is 5. Then we say y 2 is 5, and instead of wasting our space we just say y is squared 5. So that is our y, and that is like the first step, I guess. So the third step, what we're thinking about now is 1 is the rotation, rotate, and 2 is to move or dislocate, rotate and dislocate, yeah. So to move B point is first is to rotate the point. Let's make a text over here. So we say here, oh my god, move. Rotate the point so that it lies on x, no, on y axis. So we rotate the point so it lies on y axis. Shit. What did I move? What did I move? I guess nothing. And oh, okay. Rotate the point so that it lies on y-axis, and then we just move it down. Whoops. We just then move it down for the value of y, so that we say make. Alright, so at this point the B is at 0, and then coordinate bit, and then we just say here move the point to xy position. Move the point to xy position. That is just to say, if we got B, zero, and that is y minus y, and that of course gets it to be 0, 0. So that is the point for our, like, the collision point, you know, the hit point. Those are the steps that we make it the center of the new coordinate system. But can we use the same logic to rotate the other points? And more importantly, what do we do with the previous original point? I mean, it's not the most importantly, but all of the things are important. So, like, we can just like see that B was, if we look at the original B, which is over here, and the new B, which is over here, we can just say yeah, we need to rotate it also. I know what you mean. So if we just rotate it, then I guess we must also, for the same angle, rotate, for example, this C point. How do we do that? I need a break. All right. So now we know that that the B point is moved on its circle for a certain angle, if you know what I'm saying. So we then move all of the other points so this is regarding the first step, so that's first rotate and then second move. So then what do we do is basically we move all of the points for on their circle for the same angle. So let's say that same angle is over here, it looks like that. Oops. And that same angle looks like that and like that and like that. And we move it across the thing. So we say rotate. So first and here we say move points on their circle. Move points on their circle for the angle angle A that we even got on the first step. Shit. Angle A, yeah. So that's it. And yeah, so yeah, that's for now easier said than done. So how do we do that? Like over here we know how to do that. Like so how do we over here do that? Like right over here. Because what do we know in this example? We know R. We know the whole we know the whole equation for this circle right here. We know the whole equation for this circle, and then we want to manipulate the current point for the certain angle. So yeah, how do we do that? So we say not like so, maybe like so. Oh, then we make a triangle. So we say like over here this is one. Oops. Alright, so here we've got A. Shit, blink your eyes. What about now? We take the red one. Crayon, you know, we take that. Shit, let's make it a bit more straight. Yeah, we can't, fuck. Oh my god. So we take that. And for example, the square angle, we're looking for the coordinates of this point. And this is the and this here in between is the alpha, like, is it called alpha? Yeah, I think alpha. A angle. And over here we see a triangle. So we got a triangle over here. And I guess I need to do a little bit research on how to move that over there, because we cannot get like huh, that's alpha. So we say over here, like we need more of them. We say how to move a point along its circle. Is that a correct expression? How to move a point? Yeah, it's even in Stack Overflow. Fuck. All right, we're back. So we have to move a point along the circle. Make an object move in a circle without rotating. Oh, that's After Effects. Points inside, outside on a circle. Maybe this Khan Academy could help. Let's first check this thing. I want to move a sprite in a circular motion by using a circle radius and moving angle. Fair. I know, for instance, that the sprite is moving in a circle with the radius 10. Okay, that's radius 10. R is 10. And its current position is over here. And the angle is 28 degrees. Now I want to move it, say, 10 pixels along the circle perimeter. That's not the thing I've been looking for. Maybe this one. Along the circle. This needs detail, slower clarity. Movable points, Desmos. Or we can do it like in the Desmos, I guess. Inside on the circle.
At the point C, which has a coordinate, and the key is 6 units away.
Alright, that's a nice sketch,
so
actually.
If, for example, P is less than 6 units away, it's going to be inside the circle. If it's exact, and the distance formula comes straight out of to -6, so our change in y is, the key is the square root of 34, got square root of 36 here, then we'd be on the circle. And if I somehow got square root of 30...
Okay, so that gives me another idea. Like when we move it over here, it is still compliant with the equation for this circle. And we know this. So we got it over here. We want to know that the radius is, maybe if we just find out x or y. So there is one over here. Can we figure out x or y? On that alpha thing, like if we just figure this point or that point, I mean line, we are it. We have did it. And like that's a big circle, and this is the same, and that is the same, just over here. That is also, like, we could find the size of this line, but then we would need to this circle or that circle, and I don't know how to get that. Maybe there are like the other, like any other thing inside. Analytic problem solving with distance from on the coordinate plate. Alright, so moving a point along the circle, maybe like that. Is that like the exact same thing? To animate a point to trace the circle. Um, huh. So we got this thing and get there. Huh. Hmm. And we of course know like the distance between that is the same. And well, we can then there is a thing that we can do is I'm certain that we can find out the length with cosine expression, that we can find out the length of this thing, which is then the new radius, and then we then we make that into a circle. So that circle then crosses the original circle at 2 points. One is over here and one is over there, and we just then have to find out which one has, I guess, bigger. We pick the one that has bigger y property. Yeah. So we say bigger y property, so it's that one. That's a way to do it. So yeah, that's a way to do it. And we do that for everyone. So we have, for example, this. So we have, that one. So just move points in the circle for the angle A. Let me go on the Astra. What? Reserve a small satellite launch. What? It's all California. Doing crazy stuff in California. Astra .si. Wow, they did a revamp of the website. Wow, okay, so we got, it's all in Slovenian, you probably won't understand thing. Say limite odvod polinomi. We use geometria v ravnini. And then it's actually, wow. Trikotnik, skladnost, osnovni pojmi. Krog in krožnica. Radijani, obhodni in središčni kot. Why is here his signature? Pretvorbo. I wanna, like, I'm not interested in angles. Interested in point. Yeah. Let's see. Tangent, touching, circles, task 1, let's see what this task 1 is talking about, task 2, task 3, square, what's up with a square, say with, it is touching y-axis, it's going through that point, it's going through. Well, I'm looking for something where we move the point. This is just like looking for a simple equations for a circle. I want to move it. Yeah, I want instructor. Oh, this is not helping. Shit. Shit. Krožnica, krožnica ali krog, krog in krožnica. Razlaga poglavje. Yeah, that's not helping. That is not helping. Let's see how hard is that. Yeah, alright, fuck it, man. Fuck it. We'll just do it this way. Sturina maturi, yeah, fuck you. Doing the things like that is unacceptable, man. Like doing the thing that school should do, man. That's a that's shame. That's just shame, man. That's a big shame. Alright. So if we have the radius, we can get the radius of this circle by that, and yeah, we just do that. And what about here? We also get, for example, we have if we have rotate circle for like in the 1 2 3 in the third quadrant, if we have, oops, let's take another thing. Take it over here, and we do like so. So what do we do then? That's a big, oh no, we just have to get this radius, right? I mean, like so, and let's say this is alpha over here. I hope that is that. I think alpha is more bigger in that case, so I guess that's alpha, and we calculate this radius, and then we make a circle. We make an equation, and we're taking into account that radius. Alright, shit, and we're taking into account that radius, and we get 2 points. And over here, I guess again we're looking for the thing, for the point where y is bigger. Here y is of course bigger, so there's y is bigger. Alright, so that is move the points for the angle A. How do we do that? So first, well that's a long way, by the way, but first we do one, calculate the calculate the radius of the second circle to see where first and second circle of see where first and second circle of point collide. Third, calculate the 2 points which are actually candidates for a new point. For new points, calculate the coordinates of 2 points. The point with bigger y value is the new point. Nice one. That's a really nice one. Is the new point. So what about that first move? I mean that's first rotate, actually. That is rotate. We're getting mixed up with our terminology a little bit over here. Let's rotate, and then we also move it, but like, hold up a moment, like shit, like if what was I thinking about? It was, yeah, with this 0 point. What happens with this 0 point? I guess you don't rotate it, you just move it in the second part. And right now I'm just thinking about, like, what if we don't? I guess we must, like, keep account of the points that get copied from quadrants and then move them back, so they're appropriate quadrant. Make the hit point center of new coordinate system, so move points under circular for the angle A, then move, and then I guess the third point would be 3, return copied return copied points to their appropriate quadrants, to their appropriate quadrants. So how do we move it? Well, we got B here, so we want to we want to decrease B by the number Y, and appropriately we also want to decrease other. So it just move is just like decrease Y value of points by the current value of B point. So yeah, I think that is the full algorithm. I think I have just procured the whole algorithm. Oh, yeah. And I think that's it. And then now we just need to turn that into a fucking code. And how can this be 5Q thingy? Why am I always like solving higher than 5Q? Don't want to make ranking up too easy. Nope, no examples. Looks like I was mistaken. Yeah, no worries. That was a very tough and original one. Nice. Since the reference solution is scoped to the model, I managed to discover it. It's placed in tests. Reference solution. Aha. I have managed to call it, but for me it ends up with an error. Has to be set up somehow, but I think it's more of a luck than a deliberate design. Do you think the reference solution being the discoverable can be a problem? I'm not a Python person, but maybe someone more familiar with the language could abuse this fact. This comment has been hidden. It's now safely tucked inside the describe block and can be imported. Input mutation is allowed or not. Len list has a side effect of emptying the list. Okay. Adding a point to the specification on whether the input mutation is allowed or not, and if not, adding a test case to it. How could I do this less of a sudden? It's practically become a normal code words that the user can do whatever they want with the input, and this topic is never brought up unless the description is Authors do not care or do not know about the possible problems caused by mutation of the input. Users do whatever they want because they're usually allowed to. Tests misbehave. Users ask questions or raise bogus issues because their valid solution causes tests to behave incorrectly. Authors and more experienced users answer them that you mutated the input and you got what you deserve. Be gone. Nope, I personally do not think neither such questions nor the answers. I'm just looking for a way to make authors and translators aware of the problems caused by their careless approach to the topic. There's general guidance on the topic, and if there would be some language-specific aspect of the problem, you might be right that my suggestion is too strict and necessary, or the problem could be solved in some other way, and I'm open to discussion. I'm just looking for a way to force authors to write better test suites, to stop questions from users, and to stop root answers from PU. I want to make authors aware that if a test suite misbehaves because the input got modified, it's always author's fault, not the users. And how can this be implemented consistently if some languages have only mutable collections? You're right, and in hindsight I would rather suggest okay. Well, I don't know. So this dude made it nice. There's been a lot of discussion about it. Not solved a lot of times, you know? Not solved a lot of times. Yeah. Alright. Well, I think I'll just end this video right over here when we have quote unquote figured out the process. So in the next one we shall try to implement it.